A long, thin, pliable carpet is laid on the floor, and one end of the carpet is bent back and it is pulled backward. And it is pulled with a constant velocity of 1 meter per second. Now, just above the part of the carpet which is still at rest on the floor. So, this part, the one which is on the ground, is at rest, and the other part is being pulled. Now, we need to find the center of mass velocity of the moving part. Only we need to find center of mass velocity of the moving part, not which is on the rest. So before going into this problem, there is a one interesting concept here you need to understand. Whenever the mass is changing, center of mass velocity doesn't depend upon the masses. You might have learned that velocity of center of mass is m1 v1 plus m2 v2 divided by m1 plus m2. There is a different scenario where masses are constant. The m1, m2, m1, m1 plus m2, those are not changing there. But when it comes to here to the system, each and every time that some mass is being added up, after some time, more mass will be added up to the moving part. So as the masses are being added up, the center of mass velocity doesn't obey this formula. So this is not valid there. To show you that, I will take you some. Let's take we have 5 pens. Okay. So what I'm doing, I'm just placing a pen on a table. Consider for some second. Consider this to be a pen. Now just placed on the table. Okay. I'm not doing anything. Just placing it on the table. So the center of mass is somewhere here. Everyone will agree to that because it will be at the center of the pen, considering it is uniform. Next, what I will do is I will add one more pen. To this already one pen is there. I am just placing the one more pen. So here we are not giving the velocity. Now the center of mass of the system is moved to this point. You are not giving velocity, but center of mass has been changed. We'll add one more mass now, one more pen. So each and every time when I'm adding a pen, the center of mass is shifting forward. So without individual objects are moving, without individual objects are not having velocity, but center of mass is keep on moving right side. That means whenever mass is being added up or mass is being removed from the system, you cannot apply this formula m1 v1 plus m2 v2 divided by m1 plus m2. The center of mass will be somewhere here. So it's continuously moving even though individual parts are not moving. So that's whenever the beauty of center of mass actually, this concept. Now even for this also, this part, it's not at all moving during the motion, only the upper part is moving, right? So after some time, this upper part will be somewhere in this position. Now, if I ask you to find where is the center of mass of the part which is on the ground, you will say here in the center of this the part of the thread. Now, after some time, the center of mass will be here. The center of mass of the part which is on the ground, it has been shifted even though each and every particle is at rest. From here to here, each and every particle is at rest. From here to here, each and every particle is at rest. But center of mass has traveled right side. So what we can conclude from this, center of mass velocity is independent of individual parts velocity whenever mass is being added into the system or mass is being removed from the system. Now let's come back to this question now. Let's try to solve this question. So the method is easy, but the process, the idea is important. So let's take the initial situation. This is the initial situation. Let's say initially the string was here. So if this distance, so this point I call it as origin. The initial end of the string was somewhere here. I call this as origin. So if this is x, even this part will be x. Now after some time, this part is having a velocity. That's what given in the question. V is given as 1 meter per second. Now what I will do? From here, the distance of the point is 2x. So I can write d by dt of 2x. The 2x is the velocity of that end point. Let's call this as p. This is velocity of point P. which is v only, right? So 2 times of dx by dt will be v. Now here center of mass is a point which is mid of the part which is moving. So this is a point, this is a part where you have center of mass. Somewhere here we have center of mass which is at a distance of x plus x by 2. Why x by 2? Because the center of mass of this moving part will be at a distance of x by 2. And the total distance from the origin is 3x by 2. So velocity of center of mass is d by dt of 3x by 2. So solving these two equations, this equation 1 and equation 2, will get velocity of center of mass as 3 times of 3 by 2 times of dx by dt, where dx by dt is v by 2, so we'll get 3v by 4. Since velocity is given as 1 meter per second, hence the velocity of center of mass is 3 by 4 meter per second. And students might have doubt that each and every particle of the string will have same velocity v. How come center of mass will have different velocity? That's what you might have doubt. And the answer I've already explained it. If you check this previous one, center of mass is velocity is independent of individual mass velocity whenever mass is being added up or mass is being removed. So we can also explain this in a different way. So as we have taken this as one situation, after some time let's have one more diagram for this. After some time this will be the position of the string. Now look at here, the center of mass where it is located. Now this center of mass is somewhere here. Right, initially the center of mass was here, now it is here. Now center of mass has traveled from this point to this point. So it is moving in the rightward direction.